Hello, the topic is about Laplace transform. The Laplace transform is used for the transformation of a time domain signal to the complex frequency domain signal, that is to S domain. Here it is shown that the time domain signal is converted to S domain signal by applying the Laplace transform to it. Symbolically, the Laplace transform of x of t time domain signal is denoted as capital X of S is equals to Laplace of x of t, and it can be defined as Laplace of x of t is equals to x of s is equals to integration of minus infinity to infinity x of t e raised to minus st dt. And if the signal x of t is defined for the region t greater than equals to 0, then Laplace of x of t is equals to x of s is equals to integration of 0 to infinity x of t into e raised to minus st dt. Now here we can understand the Laplace transform by considering an example. Here the question is determining the Laplace transform of the wave. This is the wave and the equation the given waveform is of sine pulse of the amplitude A. So mathematically we have to first define a mathematical equation of the region. So mathematically the equation of waveform is x of t is equals to a sin t for the region 0 t between the region 0 to pi and equals to 0 for the region greater than pi. Now we have to find the Laplace transform of the a sin t waveform. So we have to first define its definition. Therefore Laplace of x of t is equals to x of s is equals to integration of minus infinity to infinity x of t into e raised to minus st dt. It's a definition about the Laplace transform. Now x of s is equals to we have to put a equation of x of t in this equation. So and its region is 0 to pi. So 0 to pi integration of a sin t into e raised to minus st dt. A is the constant, so we can take it outside. Therefore a into integration of 0 to pi sin t e raised to minus st dt. Now we know that sin theta is e raised to j theta minus e raised to minus j theta divided by 2j. Therefore we can apply it here for this sin t. Therefore x of s is equals to a into integration of 0 to pi e raised to jt minus e raised to minus jt divided by 2j into e raised to minus st dt. 2j is constant, so a divided by 2j integration of 0 to pi e raised to minus s minus j into t minus e raised to minus of s plus j into t into dt is equals to a divided by 2j. We have to integrate this term, so we get e raised to minus of s minus j into t divided by minus of s minus j minus e raised to minus of s plus j into t divided by minus of s plus j of the limits 0 to pi. Now to 2j e raised to minus of s minus j into t into s minus j minus s plus j into e raised to minus of s minus j into t s plus j divided by s square minus j square from the limits 0 to pi. Here we can take the cross multiplication of the above term. is equals to a divided by 2j into s square plus 1. J square is equals to 1, minus 1, because j square value is always minus 1. So it will become s square plus 1 and it's constant, so we can take it outside. Therefore a divided by 2j into s square plus 1 into s minus j into e raised to minus st e raised to minus jt minus s plus j into e raised to minus st e raised to jt of the limits 0 to pi. Now we have to apply the limits inside the equation. So a divided by 2j into s square plus 1 into s minus j into e raised to minus s pi into e raised to minus j pi minus s plus j into e raised to s pi into e raised to j pi minus s minus j into e raised to 0 plus s plus j into e raised to 0. But we know e raised to plus or minus j pi is cos pi plus or minus j sin pi. Therefore we get minus 1 plus or minus j into 0. Therefore we get e raised to j pi plus or minus value is equals to minus 1. Now we have to put this value into this term. So we can get as x of s is equals to a divided by 2j into s square plus 1 into s minus j into e raised to minus s pi into minus 1 minus s plus j into e raised to minus s pi into minus 1 minus s minus j plus s plus j. Now we have to simplify it. Therefore a divided by 2j into s square plus 1 into minus of s minus j into e raised to minus s pi plus s plus j into e raised to minus s pi minus s minus j plus s plus j. Now a divided by 2j divided by s square plus 1 into e raised to minus pi s into minus s plus j plus s plus j minus s plus j plus s plus j. Now x of s become a divided by 2j into s square plus 1 into 2j into e raised to minus pi s plus 2j. Pluses minuses get cancelled, minuses plus get cancelled. Therefore we get j plus j is 2j and j plus j is 2j. Is equals to a divided by s square plus 1 into 1 by 2j into 2j into e raised to minus pi s plus 2j. Therefore s square plus 1 into 1 by 2j, we can take 2j common from this term. Therefore 2j into e raised to minus pi s plus 1. Therefore 2j get cancelled. Therefore a divided by s square plus 1 into e raised to minus pi s plus 1. Therefore x of s is a divided by s square plus 1 into e raised to minus pi plus 1. This is the Laplace transform of the given waveform. Thank you.